Hello dear students, welcome to the chemistry classes. In this session we are going to discuss one of the easiest unit, that is physical properties and molecular structure. This is the second unit of BSc 6th sem paper 2 physical chemistry part. Under this unit we are going to discuss some of the introduction part and dipole moment, induced dipole moment and measurement of dipole moment by temperature variation method, and after this we are going to discuss some of the applications of dipole moment. And we know that in this universe each and every matter is made up of some kind of particles. Those particles may be molecules or atoms or ions, but the property of a matter completely depends on the properties of the particle from which it is made up of. Like that, in chemistry also, the compounds or substances are made up of some kind of molecules, and the molecules are made up of some kind of atoms or ions. The properties of a molecules are completely depends on the properties of atoms or ions. Like that, the properties of a compound or substance completely depends on the properties of a molecule. And coming to the properties, there are two types of properties: chemical properties and physical properties. Chemical property of a substance is nothing but its chemical reactivity towards the other chemicals, and physical property of a substance depends on the intermolecular forces which originate in the internal structure of a molecule. Therefore, by knowing some of the physical properties of a particular molecule, we can easily judge what type of structure that molecule is having. Some of the physical properties like surface tension, viscosity, optical activity, refractive index, dipole moment. By knowing the values for these type of physical properties, we can easily judge what type of structure that molecule is having. But for our syllabus, we have to discuss only about the dipole moment. Okay? Yes. Let us discuss about the dipole moment.
Start.
Yes. Before going to study the definition for dipole moment, here I am taking two diatomic molecules, H2 and HCl. And here in H2, two hydrogen atoms are joined by a single bond. And in HCl, one hydrogen and one chlorine atoms are joined by a single bond. And we know that single bond represents a pair of electrons. In hydrogen molecule, that is HH bond, the pair of electron is present at the center of bond, whereas in case of HCl molecule, the bonded pair of electron is situated near to the chlorine atom. The only difference is because both the hydrogen atoms have the same affinity towards the electron pair. It means the electronegativity of hydrogen atoms is the same. Therefore, the bonded pair of electron is shared equally between the two hydrogen atoms. Whereas in case of hydrogen chloride molecule, we know that chlorine is more electronegative than hydrogen. Therefore, automatically it will drag the bonded pair of electron towards its center. Therefore, the bonded pair of electrons are not equally shared between the hydrogen and chlorine atom. And because of this reason, here the hydrogen will suffer from electron density, and therefore it will get somewhat partial positive charge, whereas the chlorine is having high electron density and therefore it will get some partial negative charge, and it develops the polarity in the molecule. Therefore, we can call this one as a dipolar molecule, or we can say this one is a dipole, which is having two poles, positive pole and negative pole. And the degree of polarity is determined by the dipole moment. And here, for that, the definition is like this: the dipole moment of a polar molecule. Polar molecule in the sense what? The molecule which is having two poles, positive pole and negative pole. The dipole moment of a polar molecule is defined as the product of magnitude of charge at one end and the distance between the opposite charges. Once again, the dipole moment of a polar molecule is defined as the product of magnitude of charge at one end and the distance between the opposite charges. For this, here I am taking two atoms which are having positive and negative charge, which are separated from the distance d, which are separated from a distance d. Here this side is having positive charge and this side is having negative charge. I am taking the symbol Q for the charge. And according to the definition we can write, and the symbol for dipole moment is mu. The symbol for dipole moment is mu and its unit is Dipole. We can represent this one by capital D, and according to the definition we can write dipole moment is equal to the product of magnitude of charge at one end, and here I am taking the charge as Q into the distance between the opposite charges. Here the distance between the opposite charges is d. Therefore, to calculate the dipole moment we can use this formula. According to the definition, the dipole moment of a polar molecule is defined as the product of magnitude of charge at one end and the distance of separation between the opposite charges, that is d. And this dipole moment is a vector quantity and it can be represented by an arrow starting from the positive pole to the negative pole. This dipole moment is a vector quantity and it can be represented by an arrow which is starting from the positive pole to the negative pole. And this dipole moment is having a unit of dBA. 1 dBA is equal to 1 into 10 raised to minus 18 ESU cm. It is there in CGS system. Electrostatic unit centimeter. And 1 dBA can be also represented as 3.336 into 10 raised to minus 30 coulomb meter. It is there in SI system. And now we have to discuss about induced dipole moment. Is it clear now? Yes. Dear students, in the definition of dipole moment, we have seen that the dipole moment of a polar molecule is defined as what it is. The dipole moment of a polar molecule is defined as. What about polar molecule? Polar molecule is the one which is having two poles, positive pole and negative pole. Then what about a non-polar molecule? Non-polar molecule means what? It is the molecule which is not having any positive and negative poles. Then what is the formula for the calculation of dipole moment? Mu is equal to Q into D. Correct? Mu is equal to Q into D. Here Q is the charge at one end and D is the distance of separation between the opposite charge. And this formula holds good for the polar molecule. Then what happens if the molecule is non-polar? According to this formula, Q is the charge. Then first of all, for non-polar molecule there is no charge separation. Then automatically Q becomes 0. Then simultaneously mu becomes 0 into D is equal to 0. It means that for non-polar molecules the dipole moment is 0. Correct? But we can induce the dipole moment for non-polar molecules also. That is called out induced dipole moment. Then now we have to discuss the definition for induced dipole moment. The definition of induced dipole moment is the dipole moment created in a non-polar molecule, means the molecule which is having no positive and negative. The dipole moment created in a non-polar molecule or neutral molecule by coming into close contact with a polar molecule or any charged particle like positive or negative ions is called out induced dipole moment. Once again, the dipole moment created in a non-polar molecule or neutral molecule by coming into close contact with a polar molecule or any charged particle like positive or negative ions is called induced dipole moment. and it is represented by a symbol mu I. This induced dipole moment is represented by a symbol mu I, and the unit for this induced dipole moment is also dBA. And let me explain this definition by taking these two illustrations. Take here first, I am taking polar molecule and another one non-polar molecule. In polar molecule, charge separation is there. Therefore, we can call this one as a permanent dipole. And in non-polar molecule, there is no charges separation. Means there is no positive and negative pole. Then now, when we bring this non-polar molecule closer and closer to this polar molecule, automatically there will be a charge development takes place in the non-polar molecule. We can see here, when this AB molecule, non-polar molecule, brings from infinite distance to the or near to the polar molecule, we can see here there is a charge development takes place. Here negative charge, here positive charge. Therefore, this non-polar molecule, here it is becoming a polar molecule. This non-polar AB molecule, here it is becoming polar molecule. Therefore, we can say that here the polarity or the dipole moment is inducing on the AB molecule. Therefore, we can say this one as a induced dipole moment. Like that, if we are taking a positively charged ion, that is a charged ion, and here also we are taking one non-polar AB molecule. And when these two species, positively charged ion and non-polar AB molecules are bring near and near, there exists a charge separation between the positive and negative pole of a AB molecule, and hence this AB molecule from non-polarity it is converting into polarity, means non-polar molecule to the polar molecule, and hence we can say that here also we can get a dipole moment. Okay. Once again, the definition for induced dipole moment is the dipole moment created in a non-polar molecule or a neutral molecule by coming into close contact with a polar molecule or a charged particle is called induced dipole moment, and it is represented by a symbol mu I. And for this I am taking two examples, polar molecule and non-polar molecule. When polar and non-polar molecules are bring near each other, there exists a charge separation in the non-polar molecule, and hence the polarity is inducing on this non-polar molecule. Therefore, we can say this one as a induced dipole moment. Like that, when the charged particle and non-polar molecules are bring each other near to each other, there exists a charge separation in the non-polar molecule, and here also we can say this AB molecule gets converted into a polar molecule, and the dipole moment is induced dipole moment. Is it clear? Yes. And now we have to discuss some of the problems on dipole moment. See here, the first problem. The bond length of hydrogen iodide bond is 1.60 angstrom. Calculate its dipole moment in dBA units. Calculate its dipole moment in dBA units. If it were present in the completely ionic form, they have given the question. The bond length of hydrogen iodide bond is 1.60 angstrom. Already they have given the value of D, and they have asked to calculate the dipole moment, and that too we have to represent that in dBA unit. And also they have mentioned here that the hydrogen iodide bond is completely ionic form, and also they have given the data. The charge of an electron is equal to 4.8 into 10 raised to minus 10 electrostatic unit. See here. And the solution for this problem is already they have given the data, that is D. Inter-ionic distance D is equal to 1.60 angstrom, and we have to convert this one into 1.60 into 10 raised to minus 8 centimeter. I am converting here this in centimeter instead of meter only because they have given the charge of that ion in electrostatic unit. Instead of that, we have to take this one as a meter, but here because of this unit, electrostatic unit, I am taking the angstrom unit for centimeter, that is 1.60 into 10 raised to minus 8 centimeter. And also they have given the charge, that is Q is equal to 4.8 into 10 raised to minus 10 electrostatic unit. And we know the formula for dipole moment. We know the formula for to calculate the dipole moment, mu is equal to q into d. Mu is equal to q into d, and here we have both the values. Q is 4.8 into 10 raised to minus 10. Then the value of d is 1.60 into 10 raised to minus 8. Then after multiplying these two, we will get 7.68 into 10 raised to minus 18 electrostatic unit centimeter. And they have asked the answer in dB unit, and we know that 1 d is equal to 1 into 10 raised to minus 18 electrostatic unit centimeter. We have 1 d is equal to 1 into 10 raised to minus 18 electrostatic unit centimeter. Therefore 7.68 dB. This is the answer for this. Is it clear now? And you can also practice some more problems like this only by changing the data.